This video is to go over homework packet 7A, lesson 7.02. So let's go over problem number 5. It says complete parts A and B to show that the definition of reflection in the lesson describes a unique reflection image. So part A says given a line L and points P not on L, so it goes like this, right? So point line L and a point P somewhere over here. How many lines are there through P that are perpendicular to L? Which means how many ways can you draw? How many perpendicular lines can you draw going through P and also perpendicular to L? Of course, it's one. But why? How do you justify your answers, right? I want you to use theorem 2.5. Going back to 2.5, says if a point P is not on line L, says exactly one line through P exists that the perpendicular to L. So that's a unique perpendicular line theorem. So, well, I pretty much said all the answers, but put those ideas together in writing, and yeah. So that's part A. Part B, given a line P on a point, given a line L, a point P and another line M through P. So given a line L and a point P anywhere, and then also we have line M through P perpendicular to L. And it says explain how you can find point P prime on M such that L is perpendicular bisector of segment PP prime. Is there only one such point? So the goal of this is to explain how you can find P prime on M. So on this line somewhere over here, P prime, so that the length from P to P prime is bisected by line L. Is there any other point that we can pick in this situation to satisfy this condition? Right. So the P and P prime has to be bisected or split it by L into two equal parts, and the point has to be on line M, this line, right? Is there any other points? That sounds very obvious, but that's problem number 5 in lesson 7.02. So let's go over the next problem, which is lesson 7.03. Problem number 4, that is on page 4 in that packet. It says graph segment AB with endpoints A, 1, 2, which is 1 and 2. This is A. And 2, 5. Go 2 and 5. That's my B. Oops. Let me put it a little closer to it. And reflect AB over the line x equals 3, called the image segments A prime, B prime. So line x equals 3 is this line. The name of this line is x equals 3 because any point you take on this line, x coordinates will be always 3. So let's reflect this over this line. So you just go straight to the line, meaning perpendicular to the line, and take the same space. So it should be, B prime should be on this line with the same space. So this is P, has one space to the line, so you go one space from the line. So this will be B prime. The same thing, A prime should be on the perpendicular line to the line x equals 3. So looking at how many spaces from A to the line, that's two spaces. So you go 2 spaces from that. That's going to give you A prime. Okay? And you have part B, C, D. So this is to get you started. Let's look at lesson 7.04, problem number 7, which is on page 7. Draw triangle ABC and the point O. Find the image of ABC after a counterclockwise rotation, 65 degrees. So let's use whiteboard. Let's draw A, B, and C. And let's plot point O, and you want to rotate this figure 65 degrees. So one of the easiest way of doing it is that, or simplest way of doing it, is that you want this point A rotated 65 degrees counterclockwise. So it's this way. It's making a circle like 65 degrees. So one way to do it is to draw a line like this, O to A, right? And then you're going to use this to make it fit the center to the O and fit the edge, right? Then you go 65 degrees, 10, 20, 30, 40, 50, 65. Okay. So the A prime should be somewhere on this line. So that point P, A should move to somewhere on this line. And obviously, segment OA and segment OP prime, segment OA and OA prime should be exactly the same. So let me measure O to A. It's about 4 inches just. So I'm going from O 4 inches on the new line. So that's my A prime. Okay, and then I'm going to erase this one. You don't have to. But so you see that A moved to 65 degrees here, right? Okay, so you do that for B and C, and you'll find the new image, which is A prime, B prime, C prime. So it's that. Okay, so let's move on to lesson 7.05, problem number 7. It says, does an isometry exist that maps the circle with center O to the circle with center O prime shown below? Explain why or why not. So the answer should be yes because or no because. And I want you to think about what the isometry means. Isometry means to move things around without changing size or shape. So if I have this rectangular sponge, if I move from here to here, it's isometry because I moved it, I translate it without changing shape or size. But when I'm moving this from here to here, if I whip this off, it gets smaller, and if the size changes, we don't call that isometry. And that is about it for this lesson, homework 7A.